So this is problem 5.12 from AOPS Introduction to Number Theory. It says find the product of all of the positive divisors of 450 that are multiples of 3. Okay, so we want to prime factorize 450 to see if there are any clues to how we can find out the product of all of the positive divisor of 450 that are multiples of 3. So we just prime factorize this. We have 2 to the power of 1 times 225. 225 is 15 squared, so 15 is 3 times 5. So we have 2 to the power of 1 times 3 squared times 5 squared. That's our prime factorization. And so let's just call our divisor D. So D is a divisor of 450, and for D we want it to be a multiple of 3. Okay, so for D to be a multiple of 3, it has to at least have one factor of 3 in it. So we can have 2 to the power of A times 3 to the power of B times 5 to the power of C. And we have some conditions here. So A is between 0 and 1 inclusive, and B has to be at least 1. So B is between 1 and 2 inclusive. We also know that C is between 0 and 2 inclusive. So we have 3 conditions here. And the reason I have 1 here instead of 0, like the other factors, is because we have to have at least one factor of 3 inside D for it to be a multiple of 3, right? Okay, so how do I find the product of all of the possible D's? Because there's obviously more than 1 and also more than 2 D's. So what we can do here is we know how to find the product of all of the divisors of a number. So say I wanted to find all of the divisors of 450. So that's just my product. So I'm going to use P450 as the product of all my divisors of 450, regardless whether they are divisible by 3 or not. Then we have this P450 is going to be equal to 450 to the power of the number of divisors over 2. So the number of divisors is going to be each exponent plus 1. The product of each exponent plus 1. So let's just call this T, and number of divisors over 2. So T is the number of divisors. So T is equal to every exponent here plus 1, the product of that. So 1 plus 1 times 2 plus 1 times 2 plus 1, which is 2 times 3 times 3. That's 18. So this is equal to 450 to the power of 9. However, here we want to find the product of divisors that are powers that are multiples of 3. So we can't use this method. We want to think of a new method. However, if you just consider, so what if I considered saving a 3? Because any divisor that has at least one factor of 3 is going to be a multiple of 3, right? So how about I consider saving a 3 for my divisor so that it matches the requirements? So how exactly do I save a 3? I can't exactly book a 3 for it, right? So so my thought is like we can divide both sides by 150. And so 150 is equal to, so if we divide both sides by 3, we have 150 is equal to 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 2, right? That's the prime factorization of 150. So if we figure out, so 150 is essentially just 450 divided by 3. So if we figure out the product of the factors of 150, then basically what we do here is we can multiply the number of divisors of 150 by, so we multiply 3 to the power of T 150. So that's the number of products for 150. So we multiply P150 by 3 150, and we get the product of the divisors of 450 that are multiples of 3. So why is that? Because 450 over 3 is 150, so we've technically saved a 3 that we're going to multiply back to every single divisor of 150, and if we multiply 3 to an integer, that makes it a multiple of 3. That makes the result a multiple of 3. So any divisor here in 150, despite the fact that they may not be a multiple of 3 yet, after they are multiplied by 3, then they are definitely a multiple of 3, and they are definitely also a divisor of 450, because 150 times 3 is 450. So let's just get to work. So we know how to figure out the product of divisors in 150. That's just, so P150 is just going to be equal to 150 to T150. And we know that T150 is equal to, T150 over 2. T150 is equal to the product of all the exponents here plus 1. 1 plus 1 times 1 plus 1 times 2 plus 1. So we have 2 times 2 times 3, which is 12. Okay, so that's 12. So P150 is equal to 150 to the power of 6. So we know that 3 to the power of the number. So now basically what we want is we want to multiply the product of all the divisors of 150 by 3. And there are a total of, T150 divisors of 150, right? So we multiply 3 to the power of T150. So that just gives me 150 to the power of 6 times 3 to the power of 12. So that's technically our answer, but if we just, let's see if we can simplify it a bit. So we can simplify it a bit and make it, so let's see. So we just drag this down here, and we can make this equal to, so that's equal to 150 to the power of 6 times 3 to the power of 2, which is 9 to the power of 6. So if we combine these two, we have 0 times 9 is 0, 5 times 9 is 45, 1 times 9 is 9, plus 4, which is 13. So 1350 to the power of 6 is our answer, or I guess our most simplified answer, as it's written as the exponential form of only one positive integer. So that's our answer, and the key here is to realize that we can just reserve a 3 for 450 for the divisors of 450 to ensure that they are all multiples of 3. And so we do that by dividing both sides by 3, because we want to reserve that 3 for later. So we make sure every single divisor that we get is a multiple of 3, and we figure out the product of the divisors of 150, and we multiply that to 3 to the power of the number of divisors. So thanks for watching.